I, Ms. B. Ramani, Head Department of Mathematics, welcome you to the module Numerical Methods and its Applications. Mathematics is more than just numbers. When we think of mathematics, we often imagine numbers, equations and the classroom problems. But mathematics is much more than that. It is the foundation of a modern world hidden in it. The patterns of nature, the designs of architecture, the magic of animation and the gaming and the technology which we use in our pockets nowadays. Math is all around us, shaping the way we live, move, build, communicate and even think. In this presentation, we will explore how mathematics silently powers the world around us in places which we haven't noticed it. Now from in this slide onwards, we'll start discussing about how the real life problems will be given a mathematical model or a mathematical touch about it. I welcome you all to a fascinating journey where we bridge the gap between the abstract mathematical theories and their applications into the real world problems. So today we'll explore how the numerical methods will be giving a practical solutions for the real life problems. So we'll have a reach out for that. Now before I start with that, let me have a small introduction about how the numerical methods came into existence. When we say about the real life problems, we are into the solutions. So the solutions, how to find the solutions? There are two basic methods to find the solutions. One is the experimental method, the next one is your mathematical methodology. When I say experimental method, obviously there are two methods, one is a laboratory experiments and the other one is field observations or the study observing. Say for example, when we go for experimental studies where there are very expensive timings as well as manpower is being executed. When we go for the next type, which is nothing but the mathematical solutions, again there are two more solutions, two more methods are applicable and the other one is your analytical methods and the other one is your numerical methods. Yes, when we go for analytical methods, there are some drawbacks into that particular methods also. Say for example, as the slide shows, they are very simple, they give exact solutions for the exact modeling problem. So also they will give the answers only for the simple problems and they cannot give answers for the more complex situations or the complex problems. And they are very simple and very cost effective also. Only simple mathematical problems can be solved using this analytical methods. So these are the drawbacks into the analytical methods. So that is why it paves a way for the discouraging of the mathematical concepts. Then there is a next method called numerical methods. So here, why we study this numerical methods and what are the benefits of doing this methods. So here I can't explain the entire thing into a single module. I will just give a small insight about the basic grounding methods of numerical methods. So here in this concept, what we will be studying is nothing about why the numerical methods are applicable in the real life and what are the benefits of it. So as the slide says that the numerical methods are the techniques which applies the mathematical situations or the methodologies to solve any real life problems which has a logical touch. So what is the main approach of the mathematician is nothing but to give a mathematical model for the real life situation and then to apply any specific methodology and to build an algorithm and try to make it as a computational thing. So as we all know that all my programming concepts are based on this numerical techniques. So we'll slowly get into the numerical concepts to get the solutions. So there are humpty number of tools are available to solve any real life situations. One among them is going to be the sage math technique. So the next one is, so why we have this objective called numerical methods. So when I ask you the question, what is square root of pi or what is square root of 2, immediately people will be using the calculators and the calculator will give you the answer as 1.4, 142, 135, etc. It goes on and on. When I ask a person to write it, it's not possible to write it in real life situation. So automatically here comes the numerical methodology where it gives you the exact values what we needed. So how it is being required depending on the situation or depending on the requirement, we approximate them with a high level of accuracy. So normally numerical methods are mainly applicable in the engineering fields as well as in the diagnostic situations. Say for example, here I have used very basic concept of numerical methods which is nothing but my Newton-Raphson method. So as I said, it is mainly applicable in the science field, engineering field and in any kind of real life applications, even in the finance also it is being used. So when I come back to my Newton-Raphson method, what is being done here is, when I go for the algorithm, it is very complicated. So I made it a very simple methodology. So how it is going to be done? Say for example, I have chosen a simple equation, x cube minus 2x minus 5. So to find the solution of this non-linear equations, we will be using the special method of Newton-Raphson method. But here the same method is being given in a graphical structure. So what we are supposed to do is, we try to draw the tangent line for the given curve and with the help of the new approximations, we started doing the approximate for each and every time. So as we do the approximations, we near at a point that is called as a root of the equation. So this iterative process is based on the concept called numerical methods or the numerical analysis. So most of the numerical techniques are being an iterative process. Iterative in the sense where the steps are going to be repeated again and again until we reach the complicated or the respective solutions. So here the approximation converges to the desired accuracy. When I say desired accuracy, it might be depending on the situation. So I can go for 2 decimals or 3 decimals or 7 decimals. Depending on my accuracy, I can accurate it. So that is what the procedure says it. Yes, the next topic is your interpolation. So as the nomenclature says that interpolation is nothing but to estimate the missing values with respect to the table of values. So we will be provided with a table of values. Say for example, when we perform some physical experiments or chemical experiments or any kind of survey data, we will be comprising of some x and y data. So can we interpolate? So what does it need to study interpolation? Can we do some interpolation? In the sense estimation can be done. So estimation for the previous or the forthcoming years. Forecasting can also be done. So that technique we call it as my interpolation techniques. So how it is being used in the real life situations? So as I said, it is mainly used in the weather forecasting as well as in the medical diagnostics, because as we know that laborious experiments consumes much number of costs. So we are dependent on the numerical techniques to find whether this pharmacology or this medical is going to help that particular disease or not. So in that case, what happens, this numerical method is being paving a good solution for the real life situations. So here we prepare it as an algorithm. So whatever I said in the previous slide is being prepared in a form of an algorithm, and we give it in a form of a computational tools. So when I give it as a computational tool, automatically what happens, any real life problem can be fed into that particular computers or the systems or the softwares, and we try to get the solutions. So this is how my numerical methods is being used. So can we interpolate? Yes. A small example is being given. Suppose we have been provided with a temperature at 1 p.m. and 3 p.m. Can we interpolate what will be the temperature at 2 p.m.? Yes, you can do that with the help of this new interpolation techniques. So there are several number of interpolation techniques available, and again I have chosen a very basic and the fundamental and the repeatedly used concept called linear interpolation and the Lagrange's interpolation. So as the nomenclature says that linear interpolations where we come across a normal type of fitting. Say for example, x plus y is equal to 2. So this is what we call it as my linear. When I say non-linear, x square plus y square is equal to a square, where the powers are going to be more than 1, we call it as my non-linear interpolation. So to just have a small insight, I have chosen it as a linear interpolation. So this type of technique is also applicable under numerical methods. So here what happens, connecting any 2 data points. So if you perform some experiments or you have some real life situations where you have a data points, yes, they can be connected in a form of an equation. That connected equation we call it as my fitting a straight line, or we call it as an interpolation techniques, and that is what we call it as linear interpolation. Lagrange's interpolation also belongs to the same category, but it also applicable for unequally spaced data. There are some situations, not necessary that always my data points to be equally spaced. Say for example, when I record a temperature for every 5th minute, now not necessary that we also has to repeat the same procedure. I can record it for 5th minute, next time I can record it for 10th minute, next time I can record it for 12th minute. So there are some situations where you have some unequally spaced observed data. Can we approach the numerical methods? Yes, you can do that, and one among the method is nothing but your Lagrange's interpolation. And the last one is the application part of it. So mainly these 2 interpolation techniques are used in our real life, which is nothing but, as I said earlier, weather forecasting to estimate the temperatures between the 2 weather stations or anything else, and even it has been used in the economist as well as to find the population sizes, which is very well known everyone, and even in the sampling cases also. So these are the different real life situations where this numerical technique is being adopted. So the next one is going to be the signal processing. So again, this is one more application of your Newton interpolation techniques. So the earlier one is a specific one, fitting a straight line, and this is another methodology under interpolation techniques, and again this paves up very good applications in the part of computer graphics. So as we all know that when we speak about the imaging, signal processing and all, we want to find or we want to eliminate the blur of the image, and that can be done with the help of my numerical analysis or the Newton interpolation techniques. And the next one is financial modeling. So any financial model, they want to record the ups and downs of a market industry. Yes, they can do that, and they can predict it what will happen after 10 years, or they can find what has happened in the past years. That can be done using this financial modeling, and again this can be predicted using my numerical methods. And the third one is your geographic information systems. So again this GIS system has been working on the numerical methods techniques alone. Right, the next one is your numerical integration. As we all come across in the smaller classes, what is meant by integration? The area under a particular curve. But that regular integration or the actual integration will be solved only for the regular equations. But can we use it for a real life situation? Yes, there is another solution called numerical integration. So to find it for a real life situations, we use a numerical integration. And again, to give a small insight about it, what we used to do is, the entire curve is going to be broken up into small curves. We try to draw the trapezium, find the area of a trapezium, and repeat the same procedure for all the areas. When I sum it up, that will give you the area of the entire curve. So this idea paved the way for developing the model of numerical integration. Now under this numerical integration, there are several methods available, and the very familiar one is a trapezoidal, Simpson's 1/3, Simpson's 3/8 rule, etc. It goes on and on. And people have developed several algorithms, and they have made it in terms of computational techniques also. Yes, these are the applications of numerical integrations. So where we are supposed to use that numerical integrations, as I said, we divide the entire curve into small components or the units, and we try to find the trapezium, area of the trapezium. Same way, it is a replica of the divide and conquer rule. So you try to subdivide the entire project into small mini projects and try to solve it, find the situation or the solution for it, and then you consolidate it. Same condition has been adopted in my numerical integrations also. The next one is your approximating each segment. That is where we find the area for each and every individual trapezoid, and that will give you the simple approximation of that particular curve, and then consolidating will give you the total area of it. Then, as I said, it is going to be summed up. So the entire process is being given in terms of my small steps. Actually, this has to be converted in terms of mathematical equations. Just to give a small gist about it, I have converted in terms of conditions. Now the next one is where it has been used, in the sense this has been extensively used in the physics to calculate the distance from velocity time graph, in energy consumption analysis. In biology, very much it has been used to record the population growth, demonstrating in a versatile unity, etc. It goes on and on. So these are the various areas where this numerical integration has been adopted. And the final thoughts or the outputs after this module is nothing but where we use the numerical methods. So as I said in my previous slides, when we are bothered about the accurate solutions, yes, I can give you the approximate solutions using this numerical method techniques. So depending on the given observed data, you have to find which type of methodology has to be taken forward for that particular situation or the problem, and try to get the approximate solutions. We never guarantee the accurate solutions, but we guarantee the approximate solutions. So that is the main idea of this numerical methods. So as I said, numerical methods are essential tools in the modern world, where real life problems don't wait for the perfect answers, because when they give us a problem, they immediately want the solution. That solution can be given use this numerical technique. Keep approximating and keep solving. Thanks for watching this video. For more modules like this, like, subscribe and share M.O.P Classroom.